Welcome to this discussion about ocean thermal energy conversion, wherein we have seen about the oceans, what is the importance of renewable energy, and how using ocean thermal energy conversion you can generate renewable energy, and the economics of that, how a plant has been attempted to be set up by NIOT on a floating platform, and the various subsystems involved with that. In the next module, we will explain about the ongoing research on OTEC that is being done at NIOT. An OTEC desalination test facility has been set up. As can be seen here, we have got various water tanks and a huge tower where you have the flash chamber and the desalination condenser, etc. And this has been set up to do all types of simulation testing of OTEC and desalination. We can do the test of open cycle, closed cycle, hybrid closed cycle, and desalination with ocean thermal gradient and based on power plant condenser reject waste heat. The various OTEC equipments for the closed cycle OTEC plant are shown here. You can see the OTEC turbine, the pump, the evaporator, the condenser, and the tanks and the steel structure for housing the components. And this is the closed cycle OTEC turbine. You can see how the fluid moves during the actual simulation studies, and this is the turbine and the test setup with screw compressor, and this shows the radial inward flow turbine, how the flow takes place. Similarly, for the open cycle OTEC, the equipments are: this is the turbine, the condenser, the flash chamber, vacuum pump, and the steel structure with the flash chamber. And this is how the turbine is. You can see the flow that is taking place. You can see it here. The shaft power and efficiency has been estimated as about 77.6%, and the design conditions are indicated here. Now, we have a plan to set up an OTEC powered desalination plant at Kavaratti, an island. You can see that this is the island and this is the bathymetry. That means the depth is going more here. And we have set up already a desalination plant using the principle of low temperature thermal desalination, wherein it is a byproduct of OTEC, so to say. So now we plan to have this desalination plant powered by OTEC. So the work has started, and you see that the process and P&I diagram is similar to the one which I explained earlier. You have the turbine, the flash chamber, the condenser, and you can see that the desalination water is obtained here, and the power is again obtained using the alternator using the principle of OTEC. This is only a recapitulation. We have discussed this at length in the earlier modules. You can see the process parameters. Each of the process parameters are indicated here. For a person who is interested in doing detailed research, you can go through this and work out the parameters that is required for this OTEC powered desalination plant. And you can see this is the conceptual 3D view of the plant which is to be set up at Kavaratti Island, and we have to have a micro tunneling that is to be done in order to take deep sea cold water. This is going to be done for the first time in this part of India. And bathymetry, you see the depth of water and the temperatures are shown here for each section A, B and C. What is the temperature at nearly about a kilometer. You can see the distance from the coast is shown here, and so that we can identify which sector, either sector A, B or C, is the place where ultimately we should have it. So the final choice is sector A, taking into account all aspects of waves, currents, etc. Now here you can see the temperature of the deep water. You can see when the locations A, B and C which I explained earlier what is the temperature. The profiles are shown here, and you can also see that the temperature about 950 meters is nearly 8 degrees, and that is quite adequate for setting up this plant. And you can see the sea surface temperature also in 1415 and 1516. So the percentage of exceedance of 28 degrees is 93%, and it is 98% in 2015-16. So it is quite good to have this plant here. And for future, we want to set up a plant which is floating like this to generate power as well as water. This is part of the prestigious deep ocean mission of Ministry of Earth Sciences, which is being put up to the government for setting up a plant, OTEC plant, which will have net power as well as desalination. And this is the picture of the platform for housing the OTEC plant. We have a lot of international collaboration. India is a member of Ocean Energy System Technology Collaboration Program, which is an intergovernmental collaboration between countries which operates under the framework established by the International Energy Agency. So a subtask on OTEC has commenced with by India and Japan taking the lead, and other countries which are participating are Korea, China, France and Netherlands. Let me come to the conclusion. The conventional methods of power generations create problems like ozone layer damage, global warming, ecological imbalance, depletion of natural resources, high level of emission of pollutants, etc. That is why many countries are working in the area of OTEC, and the research is still continuing. Renewable energy projects are all capital intensive, and that is why there is reluctance from the investors to invest in this. But increasing maturity of technology and possible mobilization of high capitals due to the economic boom should change the scenario for better. And the materials for heat transfer, developments in cold water pipe systems, introduction of new power cycles in OTEC plants would definitely improve the economics, and hence it is to be taken up for future studies. Let me thank the Ministry of Earth Sciences, Government of India, under which comes our National Institute of Ocean Technology, for taking up this initiative for the country. Let me thank the team at NIOT who worked and are currently working in the area of ocean energy. This complete presentation was possible only due to the work done by my team, who were there from the year 1997 onwards and working incessantly in this area. Let me thank one and all of them for bringing up this type of a presentation to all of you. Let me thank the Saga University, Japan, the Mackay Ocean Engineering USA, who have done pioneering work in this area, OTEC International USA, and DCNS Energies France for providing lot of information and also visuals for simulation and others which you would have seen at appropriate locations. Let me thank Ministry of Human Resources Development and University of Goa for giving me an opportunity to give this talk to all of you. I hope this talk will benefit all the members who are viewing it and trying to get an insight into ocean thermal energy conversion. Thank you.